details of embedded software for hours. I wrote a book about it, so that's not really like a threat. It's not a bluff. I totally could. But I want to talk more about what I've done over my career so you get an idea of the opportunities available. And one of the things in my career that's been really important is not just the software. It's not just the hardware. It's not just learning neat things and playing really cool applications. It's the applications themselves. The times I've worked on things that weren't making a difference for the world are the times I've been unhappy with my job, with my career. And so at the end of the day, I go back to not only is this fun and is this cool and is this lucrative, but is this making me happy to have done it? So, one of the problems, how can you see this? Okay? One of the problems with embedded software is that it is neither hardware nor computer science. It's somewhere in between. I said I went to Harvey Mudd. Harvey Mudd didn't offer a computer science degree when I started there. They had engineering, which is a general engineering. It's not electrical engineering. You learn a lot of math, the Fourier and signal processing. It is so much fun. I know it sounds weird, but the world works in spinny, circular ways, and you can figure out all sorts of neat, tweaky details about it by knowing the right math. That's all engineering. When you actually want to build something, when you want to ship it, you need to know how to get from here to there. It's not just theory. There's a lot more than that. Computer science was good for that because they're a lot more accustomed to, you have to finish this project. You can't just do the math homework and turn it in. So the problem with embedded software is that you go in one track or the other. Very few colleges offer an embedded hardware, embedded software major. Instead, you end up in EE or you end up in CS, and you hope that you can do enough of the other one to get it together. If they have a robotics club at your college, join it. That is the best career advice I can give you in 5 minutes. Because that is where most of the big employers go and say, were you in the robotics club? We're back. Were you in the robotics club? If you say yes, your resume is going to, your interview is going to last a lot longer. Because that's where you get the experience of hardware and software and mechanical all together. And that's where you can actually do embedded software and have it do stuff. So I went to Harvey Mudd. I did an individual program of study where I took all of the applied computer science courses, all the ones that actually involved programming and not theory. And then I took all of the theoretical engineering courses, which are a lot of math and signal processing and how systems work together. And then I went to HP. HP was fantastic. A big company is a good place to start your career because they're sort of a machine. You know, you just crank the handle and they understand all the things you're going through. All of the, I just got out of college, how do I find an apartment? They'll help you with that. I now have an apartment, but my home life is crazy because I'm on my own for the first time. The big companies really have this process of taking new college grads and making them into, I want to say real engineers, but that's what I'm going to say, real engineers. The engineers who know how to ship things. So I am incredibly grateful for my HP days. They sent me to manager training, they sent me an engineering training. I had mentors, I had managers who actually cared about me. And since my HP days have mostly been at startups, so I really understand the dichotomy between, okay, welcome to the company, get started, you have to be finished by next week. And that is a startup culture, and it's fun, but it's not necessarily a good way to learn the industry. At HP, I worked initially on super boring computers that I don't want to talk about, but pretty quickly I transferred over to HP Labs and got to work on DNA scanners. This was 1997-ish. It was one of the very first DNA scanners on the market. And what we did was we shined laser light at a slide. And the slide, we had some DNA on it, and we had some light-up chemicals, phosphorescence, that if it was on that DNA, it would light up. If that DNA didn't match, it wouldn't light up. So if you want to know, like, for instance, if this person was at this crime scene, or this father belongs to this child, or the other way around, you can do this sort of matching to see how well things correlate to each other. And my part on that was to control the laser and to move the slide back and forth so that we could see it, and to take the data to find out were things fluorescing. Other people looked at the whole data and said, this one really is fluorescing, this one isn't, this one's iffy. But I got to move things around and move the motor really precisely, like microns precisely, widths of hair precisely. It was really cool. After HP split into Agilent, which was so long before your time, I was like, okay, now I'm at a startup, except it's not a startup, it's still a big company, and I left to go to a startup. All my friends were, and it was very cool. We made inertial measurement units. Now, I offered to talk about inertial systems, but I know that you say the word inertial measurement and people's eyes glaze over. I used to use that whenever I was like going somewhere in an airplane. It was better than being an insurance salesman. Nobody cares about inertial sensors. However, that Wiimote and how it works, the new smartwatches, and when you flip your arm over and it turns on, that's inertial sensors. If you want to know if your robot is upside down, it's probably an accelerometer. If you want to know which way north is, that's a magnetometer. And these things work together to build up navigation and speed and position and orientation. And what they do is allow us to interact with embedded systems in a way that isn't push the button. It's move the device and it works correctly. It is in its infancy. I mean, 15 years ago when I worked there, it was at its infancy. We were the first people to put MEMS sensors on the market. MEMS sensors are really durable and quite cheap. And now they cost 2% of what they cost today. So instead of $1,000 IMU, I carry around a couple of $15, $20 inertial measurement units that I just slap on things. I make them light up. It's easy because now if I want to know if somebody moved something and I want to react, I can do that far more easily. I actually have one in my bag. If you have time, I'll bring it back. So one of the things I got to do was to go 180 miles an hour in a race car because we were working with a company that monitored NASCAR. I also got to work on tractors because when you have a farm that is 100 miles long, you need the tractor to go in a straight line, and not a GPS straight line, which is pretty straight, a really straight line, because 1% deviation made a huge difference. Unfortunately, oh, and we also did airplanes, which was very cool, and I got to do lots of documentation for FAA. You want to know why planes don't fall out of the sky? It's because they're held up with all the piles of paper that you have to generate in order to put anything in an airplane. But one of the other things inertial measurement units do is bombs. And I did not realize how much that was going to bug me until we got a unit back. It had gone to Iraq, and it had been a bunker buster. They didn't work at GPS for the last bits. And so this one was smashed. It was still, its light was still blinking. So I was happy it was still working, but it was really destroyed, and I didn't like it. Going to MUD, they do a lot of humanity. There are a lot of how your engineering works with the world. But I still believe we were the good guys, so bombs, I didn't think it would bug me, but that thing on my desk that showed an explosion had happened and I'd helped it, that bugged me. Race cars was fun, tractors was useful, airplanes was also really useful, although in strange ways. But once I had that device smashed, nearly unrecognizable, if you had offered to let me be a kindergarten teacher instead of an engineer, I would have taken it. I mean, without hesitation, which was good because my next job, like a month later, was working at LeapFrog making educational toys. Anybody have any of these toys? Good. I mean, not good because they're cool toys, but cool. When you think about toys, if you have something that has the alphabet on it, has the whole alphabet, right? When LeapFrog started in the late 90s, Fisher-Price would make an alphabet bus, and it would go A through F, because that's all that fit comfortably on the bus form factor. And LeapFrog said, no, that's not an educational toy. This is an educational toy. And I got to take some of my toys to classrooms, to kindergartners, and I got to see them use them. LeapFrog, paid half my time there, and I volunteered half my time there. And I got to see how the children would interact. It was an excellent way for me to understand how my software was not doing what it should. If it's not engaging, then it's not educational. And this is where I learned about how pennies really matter when you're making a lot of something. And the different process you go through when you're trying to make 100,000 or 1 million or 10 million devices. It's a lot different than what you're doing if you're building it in the garage, or if you only need to make 100 of this special type of unit. Large-scale manufacturing is really cool. If you're looking, I'm going to build this widget this summer, I'm going to kickstart it, I'm not going to go to college because I'm going to make $1 million that way. Let's talk. It's easy to have a successful Kickstarter. It is very hard to have a successful Kickstarter and ship a product. So, be careful with that. But working with the kids, working with the toys, and being able to say, oh, I taught a kid his alphabet by letting him take home my device, and he came back the next day and he knew, and he hadn't before, he was behind the other students. It was magical. It was the sort of engineering that I hope you all find. That is an AK-47, which is not legal in California, although that one was. I talked a little bit about gunshot location system. And for the people who came in, the morning people got to choose what I was talking about, so this is their fault. ShotSpotter is the gunshot location system, and they were a tiny, tiny company. We were working out of somebody's backyard. And the idea was you sprinkle sensors around a city and automatically call the police when a gunshot goes off within the coverage area. It's in more than 50 cities in the US. We have them locally: Richmond, Oakland, East Palo Alto, Redwood City, although that's kind of a test bed more than a danger zone. But also Washington, D.C. and Boston, even internationally, there are some places in Brazil. And the stories there were quite amazing. Finding out that the pregnant lady hadn't died after she got shot because we got the police to her in time. And that's the sort of thing that makes a crappy engineering day a lot better. And the hostage situation that the police would never have gotten there in time to talk the guy down because he had drugs in his system, and a few more minutes they would have been worse. That's really cool. And when you talk about machine learning, ShotSpotter was such an amazing thing for machine learning, because the difference between fireworks and gunshots, that's pretty easy to tell, strangely. I mean, they both make boom sounds, but one of them sometimes makes crackle, crackle, or... And gunshots are very, very loud and have special characteristics. Strangely, the difference between a machine gun and a helicopter is not as big as you would expect. And so I got to spend a long time trying to get our algorithms to use the different machine learning techniques and the different signal processing techniques to be able to tell the difference, so that we didn't send the police out because a helicopter was wandering around. That's a pointless use of their time. We wanted to send them out with the knowledge of how many shooters were there, and how many guns were there, and how many people were still shooting, and how many people were hurt. Now, ShotSpotter can't tell you how many people are hurt, but they can tell you all the rest of the stuff. And for a drive-by even, they can tell you which direction the car was going. A feature that was used actually quite a lot in Oakland. ShotSpotter was really, I want to just keep saying ShotSpotter was really cool, because it was. But it also was pretty violent. After 4 years of being there as an engineer, and then a manager, and then a director, and I kept getting called when there were murders in Washington, D.C. because they needed a little more information. Now, if somebody dies in Washington, D.C., I think that's sad, and I feel bad for their family. I don't want to be on the list. I don't want to be 5th on the list. I don't want to be 50th on the list. I don't want to find out. I like to live in my own little world. So I did eventually move on from ShotSpotter. They are still going very strong, and they're still a great company. But this is sort of my graphical resume. DNA scanners and tractors and toys. Before ShotSpotter, I did a little bit of MP3 before MP3 was a standard. I worked on ICU temperature sensors for people. About a month before we shipped the product, a month after we shipped the product, I needed one, so that was sort of karma. Sadly, spending some time in ICU, but being able to look at the nurse and say, I made that, was, it was very surreal for her. The whole thing was pretty surreal for me too. I wrote a book. Down here I did something, my notes don't say. Oh, credit cards and thumbprints. Now that the iPhone has taken over and we can pay with our iPhones, that's cool, but there was a project to do that. I worked at Fitbit for a while before they got big, and worked on their algorithms for step counting and for weight tracking. And I did a robotic exoskeleton for helping people relearn how to walk after a stroke. One of the big problems with relearning how to walk is that you don't trust your limbs. And that's why maybe your grandparents like hold their leg out and you kind of swing it around. That's because it's safer to do that than to wonder if your hip and knee are just going to pop you on the floor. So the exoskeleton would support the body and actually move the leg at times when it couldn't, and teach you to trust your system. It never shipped, and I'm really sad. Since this, I mostly work with little startups. I have gotten into this position where people come to me with their ideas, and I can make a prototype, and I can hook them up with somebody who can make a product, and I send them off. And then occasionally I get people who are at the last stages, they've finished their product and they can't quite ship it because they forgot 1 or 2 firmware features, and I come in and get to fix it. And it's fun. I mean, I really like what I do because I get to work on all kinds of stuff. I still do a lot of medical, I still do a lot of inertial, but I also, you know, make blinking lights for bike directions and weird things like that. One of the other things that I have gotten to do, partially from the book, partially from having a podcast, is to be a Hackaday prize judge. Have you heard of Hackaday? I believe at the end of this, if I remember what Robin told me, you have to make a web page to talk about your project. Hackaday is what you can do if you're not here and want to do that. There are all sorts of project pages. Like, for example, my page has a ring that I made. It has a screen on it, and I talk about how to build the ring and where the code is and where to buy the parts. And I do it in such a way that I want other people to build it. And so that's what Hackaday does. And the prize is a trip to space, or about $200,000 I think it will cost. And it goes from here to August. And they give out lots of littler prizes, like every week. So if you want to go and make a Hackaday page, I recommend it. And if you want to talk more about Hackaday, I can do that. But their goal this year, the prize winner, is going to be making a social impact, doing something for someone else, some ideally big, giant thing. Last year's goal was about connectivity and connecting people and space, and it was not as well defined as this year. It was their first time. But the winner was SatNogs, and what they do is they tell you how to build a ground station to listen to satellites. And they do it in such a way that, you know, I could easily build that in a weekend, so could you. I mean, they really make it, they provide the code. Once you've built yours, you can go into their network of ground stations and listen to satellites. I know that there are some high schools and some colleges that actually put up little tiny satellites that pretty much say hello world, but they teach you about how to build aeronautic things, or aerospace things. And this lets you listen to all of those, as well as all the weather station and all the encrypted things from the government. You may not be able to decrypt them, but you can listen to them. But there were other things that were just amazing. The guy who made a spectrometer to look at the chemicals in his water, he'd never done anything like it. And he just wanted to know what was in his water, read about this, and decided to try it. The person who made an quarter, which was an Arduino tricorder, and it didn't actually, it didn't do the medical stuff, but it had all these little sensors you could take in and out and easy software to put together. So even if you don't want to do a Hackaday page, maybe go check it out, because there are a lot of people who have done neat things. And the goal is not only to do neat things, but to share how you did it. And I hope that's one of the things you get from this program, is that it's not enough to build the neatest, coolest robot possible. You have to tell other people about it. You have to make it so they can build it too, and so they can participate. And it's not just showing off, it's not just bragging. This slide is a little bit of bragging. So I understand what that is, but it is helping other people, and it's getting their help in return. I have been astounded at the number of people who will read my posts or my projects and say, have you heard of this processor? Or have you tried that? Or this isn't working for me, so I did it a totally different way and I like it better than your slides. Here's how I did it. And then they give it all back. The community is pretty amazing. So, keep that in mind. This is some of the things I've written, articles, book, patents, whatever. And that's me, and I'm about out of time. I have stickers for my podcast. It's a weekly podcast about embedded software, mostly, embedded hardware. We talk about everything from doing a Kickstarter to, this week was how to minimize power on Arduinos and how to choose power-efficient chips. Sometimes it's really technical, sometimes it's about art, sometimes we did one about blowing glass because I was interested in that. So, that's questions. Really? Just one. That'll make me feel better. Just one. Yes?
So how did you guys distinguish between the differences of gunshots? So if there was a gunshot or something that sounded really close to a gunshot, how did you guys distinguish these two?
If there was a gunshot and a what?
And something that sounded a lot like a gunshot, but it wasn't actually a gunshot.
Well, there are a couple of ways. If you were listening to a gunshot at 100 meters away, it sounds like pow! And if you're listening to it from a mile away, it sounds doorknob. And so the sensors themselves would have lots of impulsive events, just a minute. And basketballs would set them off, and car doors, and backfires. But gunshots are really loud, and that's one of the things that works for the system, is it has to be heard across a big distance. Another thing for gunshots versus like M80s, which are explosives, and actually most police want us to set off the system for that level of explosive event. Those are pretty hard. Not impossible, because an M80 has a woomph sound that tends to follow it, and gunshots tend to dissipate really quickly. From a human perspective, something we couldn't put into a machine learning algorithm, gunshots are often followed by dog barks. A lot of dog barks. So, that's the sort of thing we would tell the dispatchers, listen to the gunshot, and, if you get dog barks, definitely dispatch. Also, 4th of July, New Year's Eve, those are high firework times, so we'd be a little more critical on that. But it was high firework times at like 9 or 10 p.m., not at midnight. So, there were over 100 different characteristics to look for.
A couple things. First off, did you program the machine? Did you measure, types of calibers, different bullets, different handguns, rifles from distances, and program those characteristics in?
That's a really, really hard proposition, so not so much.
Okay.
We did go out to the Mojave Desert in August and melt off my hiking boots in an effort to get that data. So we had it, and we could tell in certain circumstances. I mentioned about the whole Washington, D.C. and being on call. That was the sort of thing we would do when absolutely necessary, and we would do it by hand and with our own personal algorithms that weren't deployed on the system.
Okay. And the second thing is, I'm kind of curious what the legal implications for that would be. Like, for example, you get police dispatched to a potential gunshot. What then? Do they knock on doors? Do they, you know,
Depends on the situation.
raid people's houses?
Oh, I hope not.
Okay, I hope not too.
No, for holiday gunshots, New Year's Eve, they would go the next day and put on door knockers and say, we believe there was a gunshot in this area, did you hear anything, give us a call. Nobody would call, but the next year nobody would fire guns in the air. So that was considered a huge win.
Okay.
I'm thinking about some of the stories that I know are public, so I'm trying to make sure I share the right ones. There was an incident not too far from here where there was a drug deal gone wrong behind a building. Unfortunately, that building was adjacent to an area where they often had drag races. So as soon as there was a gunshot fired at the drug deal, all the people at the drag races felt like they needed to see whose gun was larger. And so the officers dispatched, or the dispatcher sent a number of officers. It would have been unsafe for just one. And once there, mostly the presence and the presence of the ambulance, because people were injured, calmed the situation down. I don't know of any cases where they broke down the door.
Okay.
For one thing, ShotSpotter can't hear very well inside. So if you're going to commit a murder, make sure to do it inside.
Okay.
Or don't be in a ShotSpotter coverage area. Anything else? Yes?
You had said the exosuit didn't end up shipping, or the exoskeleton for helping patients rewalk again? Oh,
It didn't ship.
Why?
Which for me sucks, because I love shipping products. I love seeing my things on Target's shelves or in the right place.
So why did it not ship?
Funding, mostly.
Funding?
One of the problems with working at startups is they fail. It is heartbreaking almost. And that one, the patents and software and hardware haven't been bought by anybody. Usually startups, they get, at least something gets bought and carried on. There were a lot of things wrong with that startup, and I have to admit I was so attracted to the application and the hardware that I didn't really do enough diligence on, is this company viable? They aren't always. One of the great things about what I've gotten to do is, after spending a time, mining salt and putting my work in, I can go after these weird niche things that may not succeed because it isn't as important to have daily kibble brought home, So now I can go and try stuff. Anything else? Robin?
In the startups that you've been in that succeeded, what are some commonalities you've seen that contribute to success?
I'm a consultant. That means that I don't work for companies directly. I worked at HP, I worked at Crossbow, I worked at LeapFrog, but then I started out and I made my own company, and I just help people. And one of the things that I don't do anymore yet is I don't love products. I like them, I enjoy them, I find them adorable, but I don't sink my life into them. Someday there'll be another product that came by. I said I was never going to do it again after LeapFrog and all the toys, and then ShotSpotter came, and clearly I fell in love with that product, and I worked for that. But as a consultant, I work for money, which isn't bad because it leaves me time to do stuff like this. But the thing that works, that makes startups work, is not only having a CEO who knows what they're doing, not only having an engineering manager who has been through this before and who understands schedules and shipping. You have to have people there who love the product, who really believe in it, and not just in a, this is a good idea, this is a neat technology sort of way that I bring to the table, but in a, I want this thing to exist desperately. And that's what startups need in order to succeed. How's your startup, Robin?
Chugging along.
Anything else? I have embedded stickers if anybody wants them.